Okay, next one, example 13. So a vacuum parallel plate capacitor has plates of area 150 centimeter square here and separation of 2 millimeter. So the capacitor is charged to a potential difference of V0 2000 volt, and then the battery is disconnected and dielectric sheet of the same area is placed between the plates. So in the presence of the dielectric, the potential difference across the plates is reduced to 500 volt. Okay, now let's highlight the important information first. Okay, so initially, this this capacitor is connected to a battery. So we have a battery here, which is 2000 volt, and then this one is capacitance is not given. And then what happened next is battery is disconnected. So now kita tinggal dekat sini hanya ada capacitor sahaja. Because the battery is disconnected. And the potential difference across this capacitor is now equal to 500 volt. Okay, now equal to 500 volt here. So we know that, apabila dielectric is inserted, so contohnya ada dielectric lah dekat sini, capacitance will increase. So capacitance will increase, but we are not given the value of capacitance. So another information that we have is the area, which is 150 centimeter square. So ubah kepada meter. And then the separation is 2 exponent -3 meter. Okay, now question A. Okay, determine the initial capacitance and initial charge of the capacitor. So initial ni adalah semasa belum lagi kita letakkan dielectric. So this one initial, this one is final lah with dielectric. Okay, so now we want to find the capacitance, initial capacitance and initial charge. Okay, so kita ada dua sahaja value, formula untuk C dekat sini. So we either use C is equal to QV, or we can use C0 is equal to E0 A divided by D. Okay, since dekat sini we cannot use this one. This one we cannot use sebab kita tiada value untuk Q. Sebab kita mau dua-dua value ni kan, C dengan Q. So we cannot use that one. So we can find this one. Okay, we can find the C first. Okay, using this formula, C0 adalah the initial one. So E0 adalah epsilon permittivity of phase space. So constant 8.85 exponent negatif 12 darab dengan the area 150 exponent negative 2 and divided by the distance, which is 2 exponent negative 3. So akan dapat the initial capacitance, which is equal to 6.64 exponent negative 11 farad. So now that we have the C, we can find the Q. So Q is equal to CV. Okay, sorry, tadi ni tersalah formula. So just ignore that one. Q is equal to CV. C adalah value yang kita kira tadi. And then V dekat sini adalah V0. Okay, initial kan? Sebab initial, so 2000. So you will get Q will be equal to 1.32 exponent negative 7 coulomb. Okay, so that will be for question A. Okay, now question B. Determine the capacitance after the dielectric is inserted. So now we want to find this value of C dekat sini. Selepas diletakkan dielectric. So still using the same formula. C is equal to C is equal to Q over V. Okay, let me padam dulu ni. Nanti kamu ikut pula yang salah ni. Okay, C is equal to Q over V. Okay, Q akan constant. Okay, remember kalau kita disconnect battery and then letak dielectric, okay, Q dia tidak akan berubah. Q will be constant here. So we will use the same value of Q dekat sini, this one, which is 1.32 exponent negative 7 divided by the volume, the voltage. So voltage now is reduced to 500. So boleh dapat capacitance 2.66 exponent negative 10. Okay, itu adalah question B. Okay, next one, question C. Okay, determine the permittivity of dielectric material. So permittivity of the dielectric, right? So permittivity is this one, epsilon. Because we have epsilon R, epsilon, and epsilon naught. So you need to know, okay, the difference between all of these three. So epsilon R is dielectric constant. Dielectric constant. And this one is permittivity of dielectric. And then this one adalah permittivity of free space. Free space maksudnya in vacuum. So this one adalah value dia constant ya. Value ni adalah constant. So we want to find this epsilon here, which is permittivity of dielectric. So using the formula of epsilon R is equal to epsilon divided by epsilon naught. Okay. Do we have the value for epsilon R here? Okay, actually we don't have the value of epsilon R, so we cannot use this one first. So the continuation adalah C over C naught equal to V naught over V. Okay, so this one we don't have this value. Okay, value ni kita tiada. V naught kita ada, V pun kita ada. So this one kita ada. What else? This one, do we have this one? C and C naught kita ada. Okay, because we want to find this one kan, kita mau adalah value ni kan. So in order to find this value, we need to find this value first. Okay, this one first kita kena cari. Since kita ada value ni, this one ada kan. So we can find, okay, epsilon R is equal to V naught divided by V. V naught adalah the initial value tadi adalah 2000 volt divided by the V, which is final value, which is 500. So epsilon R will be equal to 4. So kalau macam tu, bolehlah kita cari the value for the dielectric. So epsilon R is equal to epsilon divided by epsilon naught. So here will be 4. This one is the value that we want. And then epsilon naught adalah value yang constant, which is exponent negative 12. So dapatlah the permittivity of dielectric, which is equal to 3.54 exponent negative 11, okay, coulomb square per Newton per meter square. Okay, ni wajib tulis the unit here. Kalau tidak hafal unit ni, kamu boleh tengok je lah dekat list of constant, because dia adalah sama value dengan this one, epsilon naught. Okay, so that will be for question C. Next one, question D. Okay, determine the change in electric field after the dielectric is constant. Okay, we know that dekat sini kan, so initially, okay, kita akan ada value E naught. So bila diletakkan dielectric, since voltage reduce, okay, electric field juga akan reduce. So how do we find this? Because dia mau adalah the change. Maksudnya, okay, soalan D maksudnya delta E, which is final, okay, initial minus final. Because initial dia akan lebih tinggi kan electric field berbanding dengan final. So we find the initial first. How do we find the initial? So we know that the formula is E naught is equal to V naught divided by D. V naught tadi adalah 2000, and then the D will be equal to 2 exponent negative 3. So dapat the electric field for the initial one, 1 exponent 6 volt per meter. And then boleh cari pula untuk final. V divided by D. V adalah 500. Okay, D dia masih juga sama, tidak berubah. So akan dapat for final will be equal to 2.5 exponent negative. Sorry, exponent 5 volt per meter. So delta E is equal to E naught minus E. So 1 exponent 6 minus 2.5 exponent 5. So akan dapat 7.5 exponent 5 volt per meter. So that will be for the change in electric field.